Good day, everyone, and welcome to another edition of Least Common Multiple. That's right, the game show where you, the person watching this video, gets to learn how to find the least common multiple of two numbers with moi. So today I'm going to be going over how to find the least common multiple of 8 and 6. Well, one of the first ways you can do it is by simply skip counting. So it does help to know your times tables. Skip count with me. Let's do it together.
8, 16, 24.
And that's it, right? We skip count until we come across a number that we think is going to appear on both lists when we skip count. So now let us skip count by sixes.
6, 12, 18, and 24.
And there you have it, folks. The least common multiple of 8 and 6 is in fact 24. And now we come to the 7 and 3 problem, which is not a problem at all. All we have to do is count by 7s and 3s, and we'll find it.
7, 14, 21.
Now let's count by 3s.
3, 6, 9, 12, 15, 18, and 21.
That's right, folks. We have found the least common multiple of 7 and 3 by simply skip counting until we found a number that appeared on both lists. The smallest number, the least common multiple. And now we come to yet another example problem, 4 and 22. Now, this one, we can clearly see that 22, if doubled, is going to equal 44. 22 plus 22 is 44, and I know for a fact that 4 will in fact go into 44. 4 times 11 is 44. However, just for kicks and giggles, let us skip count by 4s.
4, 8, 12, 16, 20, 24, 28, 32, 36, 40, and 44.
There you have it, my friends. 44 is the smallest number to appear on both lists. Therefore, 44 is the least common multiple of 4 and 22. And now we come to your friend and mine, 16 and 24. And it is the same strategy that we've been using before. We simply skip count by 16s. And again, if you don't know your 16 timetables, you can simply do 16 plus 16 on the calculator, and then just continue to hit equal, and that will spit out all the multiples of 16. So what we have here is we have
16, 32, 48. Now I'm going to stop at 48 because I know that 24 will divide into 48.
So let us count by 24s.
24 and 48.
Now we have found the smallest number that appears on both lists. Therefore, the least common multiple of 16 and 24 is 48, using the list method. And now we come to 10 and 23. Now, this one looks a little peculiar because 10 and 23, 10 looks good, but 23, have you ever counted by 23s before? Let's go ahead and try the listing method and see what happens. Let's first of all count by 10s. So we're going to go ahead and go
10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Well, so far I don't see anything 23 will divide into evenly. Let's keep going. 110, 120, 130, 140, 150, 160, 170, 180, 190, 200. I still don't see anything that 23 will divide into evenly, so let's keep going. 210, 220, oh wait, 230.
That totally works because 10 times 23 is 230. So I know that'll work, but let's count by 23s just to be sure. And again, grab your handy dandy calculator and do 23 plus 23, and then just keep hitting the equal sign to count by 23s.
So we got 23, 46, 69, 92, 115, 138, 161, 184, 207, and 223.
Now, 230 is the smallest number that appears on both lists. Therefore, 230 is the least common multiple of 10 and 23. But let me show you a trick that will make this a little bit easier for you. And that's using a method that involves prime factorization and this little Venn diagram thing over here. So let me go ahead and make some space, remembering that the least common multiple of these two numbers is 230. And let's go ahead and erase what we have. And let's try those methods and see if it's a little easier. The list method's not too bad if you got a calculator handy. You just have to be patient. But let me at least show you this. All right, so prime factorization. Let's start out with 10. We use a factor tree and we break it apart. What are two numbers that multiply together to equal 10? Well, we know that 2 and 5 multiply together to equal 10. 2 times 5 is 10. And let's do the same thing with 23. What two numbers multiply together equal 23? Well, 23 is prime already, so all we have to do is do 1 times 23, and we have the prime factors. Remember, all these numbers need to be prime on the bottom for it to be the prime factorization of that number itself. So the next step is we would use a Venn diagram just to help organize things a titch. So let me make this Venn diagram bigger. And we can organize our numbers in the Venn diagram. very simply, as soon as I find my pen, we can let this side represent the prime factors of 10, and this side represent the prime factors of 23. And then, of course, the numbers that they both have in common would go in the middle. So here we have 2. So we're going to go ahead and put our 2 over here. And we have a 5, and we'll put our 5 here. And then here we have a 1. So we'll put a 1 over under the 23. And we have a 23. So we'll put our 23 over here. Now you notice as we look at both sets of prime factors, they don't have anything in common, so we don't need to put anything in the middle. That looks like a 3, doesn't it? We don't need to put anything in the middle. But what this does tell us is that we can now simply multiply together those numbers to find the LCM. Let's see if it works. If we do 2 times 5 times 1 times 23, we should come up with 230. Let's try it on our calculator. 2 times 5 times 1 times 23 is in fact 230. So the least common multiple can also be found using this method. It is in fact 230. Welcome back, everyone. Now we are going to do the least common multiple, or discover the least common multiple of 10 and 19 using the same method we used just before this one. So let's use prime factorization. We know that 2 times 5 is 10, and the prime factorization of 19 is going to be 1 times 19. Now you could organize it over here, put all the factors of 10, which is 2 and 5, prime factors, and all the factors of 19 over here, which is 1 and 19. But all you need to do to remember, since they don't have anything in common, is that we can just multiply those numbers together to find the least common multiple of 10 and 19. So let's do that real quick. 2 times 5 times 1 times 19. So 2 times 5 is 10, 10 times 1 is 10 still, and 10 times 19 is 190. So the least common multiple of 10 and 19 is actually 190. Don't believe me? Ask the dishes. And finally, we come to 64 and 12. We could do the listing method, but let's try to find the prime factorization and use a Venn diagram to make our lives easier. Shall we, people? Whoever's watching this, let us do this. Shall we? Yes, I already asked that. All right, so we're going to take 64, and we're going to break it apart using a factor tree. What times what equals 64? Well, 8 times 8 fell on the floor, picked it up, and it was 64. We can now break apart these 8s because they're still composite. We know that 2 times 4 is 8. We once again know that 2 times 4 is 8. But we still need to continue to break this apart. 2 is prime, so we can carry that down. 4 is composite, so we'll break that apart into 2 times 2. 2 is prime, so we'll carry that down. And then 4 is composite, so we will break that apart into 2 times 2. Now, that should be all the prime factors of 64. There's a lot of 2's. Check this out. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So that's how you know that you have the prime factorization of 64. It's if these numbers on the bottom multiply together to equal 64 and that they are all prime, meaning they have 2 factors, 1 and the number itself. So let's go ahead and organize all of our 2's, if you will, into this Venn diagram. So we're going to put our 64 right here. And then how many 2's do we have? 1, 2, 3, 4, 5, 6. We got 6 2's. So we're going to put all 6 of them in that particular side of the circle. Just for now, people, relax. Don't scream at your computer screen. But we got 6 2's. 2, 2, 2, 2, 2, and 2. Right? Right. Okay, now we need to find the prime factorization of 12. So I'm going to put 12 right here, and I'm going to use a factor tree for that as well. Break that apart. We know that 3 times 4 equals 12. 3 is prime, so we're going to carry that down, and 4 is composite, so we're going to break that apart. 2 times 2 is 4. And those are all the prime factors of 12. We know that because 3 times 2 is 6. 6 times 2 is 12. And those numbers are all prime on the bottom. So let's go ahead and put those factors over here. So these are the factors of 12, prime factors of 12. 3, 2, and 2. Now, here's where the fun part comes in. This is where the handy-dandy Venn diagram can be helpful, because we can actually use that middle part to organize some of the factors that both these numbers have in common. For example, if you'll draw your attention over here, we have a 2 over on this side, and we have a 2 over on this side. Therefore, we can put them both in the middle, and they disappear from their sides. Once again, we can look over here, and oh, we have a 2 over here. And we also have a 2 suspiciously close to the middle right there. We can organize them by putting them both in the middle, and boom, that disappears. And now, for the fun part, we can simply multiply them all together. So it would be 2 times 2 times 2 times 2 times 2 times 3, right? And that's how we would organize it. So the ones that they have in common, we put in the middle because we only want to multiply them together once. And this theoretically should give us our least common multiple. Shall we try it? We shall. Let's do it. Hold up, I'm going to put it up here. So we got 2 times 2 times 2 times 2 times 2 times 2 times 3, right? How many 2s do I got? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and then 1, 3. Okay, so let's go ahead and do the math there. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. And 64 times 3 is 192. So, theoretically speaking, the prime factorization should be 192 of 64 and 12. So let's put 192 over here. And just because I've got time, you got time, we all got time, let's go ahead and do the list method just to make sure. Just because I know you're like, well, can't I just take a calculator and can't I just like keep adding it and listing it and then come up with a correct answer? Yeah, you totally could. I'm just trying to show you an easier way. So relax, people, relax. So let's go ahead, grab our calculator and do 64 plus 64. And then if you hit your equal button over and over again, it'll help you count by 64s.
So we got 64, 128, equal, and then 192.
Boom, I already made it to 192 on that side. Now let's count by 12s. For those of you that know your 12s times tables, say it with me, children.
12, 24, 36, 48, 60, 72, 84, 96, 108, 120, 132, 144, 156, 158, 180, and finally 192.
There you have it, folks. We have confirmed it with the list method that 192 is, in fact, the least common multiple of 64 and 12. Pen drop.